Of all the dimensions known to man, there is only one in existence that you can enter, where three-dimensional printing meets the bone zone.
In this video, using the most recent version of Cura 5.0, I will walk through all the settings I personally use in Cura, which is about 100 or more different slicing settings. For a quick reminder, I'll go through a basic slice. Click the folder in the top left to open a file of a model. Once placed, left-click to select the model to be able to move, scale, and rotate in the X, Y, or Z directions. Either by clicking this move button option on the left bar or hitting the T key, the model can move around the build plate. Models can be resized in any axis by either clicking the scale option or hitting the S key. Models can be rotated by any axis by clicking this rotate arrow option or by hitting the R key. Moving on, right-clicking gives some more options for centering, multiplying, or deleting models, and more. Remember to keep the model within the build plate area, noted by this dark gray boundary. Cura will tell you when a model is not placed correctly and will not slice, to help avoid bad G-code. The current settings are top right. After slicing, click Preview to view the sliced model. When slicing, keep in mind that some models might need support structures when there are floating parts to help the machine print properly. Also, the color scheme for the sliced model is under the line type, so cyan is helper lines like supports, skirts, brims, or rafts. Red is outer line or shell, green is inner line, yellow is top and bottom skin, and orange is the infill. With a nice looking sliced print, save the G-code to either your local files or the USB to mini SD card. Hovering over the eye bubble icon shows some more details on the print time and material usage. Before getting into my settings, I want to walk through a G-code file quickly to show how the system works. I open a G-code file with Notepad++ and can see right away this file has many lines. This is what is produced from the slicer, and these individual instructions are driving the motors and thus the machine to print the model. Each instruction is a line of G-code, which comes from Computer Numerical Control, or CNC, and is mainly used in computer-aided manufacturing, or CAM. It is instructions that tell the motors where to move, how fast, etc. And with 3D printing, is used to communicate and control all the motors, heaters, fans, auto bed leveling, and other components in a 3D printer. The Creality machines run off the Marlin flavor of G-code. Some quick ones are the G1 to move a motor linearly, G28 to auto home, or M140 to set the bed temperature. I'll leave a link in the description for Marlin G-code. Changing these settings, parameters, post-processing, or more within Cura will produce slightly different or even more complex G-code. Getting these instructions just right to best match with how your machine acts is the key to success and beautiful prints with minimal failures. Continuing on now to some more advanced tools. In the left bar under Move, you can enter values or click to lock the model. Under Scale, you can enter values or click Snap Scaling to scale by a snap percentage, or click Uniform Scaling for symmetric scaling on all axes, or click Reset. Under Rotate, you can click Reset, Lay Flat, Snap Rotation, or select a face, which is a favorite option of mine to make sure the print aligns and starts on the surface I want. Models can be mirrored with this mirror option or by hitting the M key. There are some mesh types under this per model settings here. There is Normal Mesh, Print as Support, Modify Settings for Overlaps, or Don't Support Overlaps. There is a really cool option that I have not tested out myself, but you can customize individual settings for this specific model here by clicking Select Settings. This last option can block support generation from an area that is selected. This does just what it says. Block support from generating in the specified area you click. Besides saving G-code, a project with models can be saved. Click File, then Save, or press Ctrl and S to save the Cura.3mf file. Make a new project under File, or by pressing Ctrl and N. Or open a model or Cura project under File, or by pressing Ctrl and O. I find the default settings enough to get started with slicing and 3D printing, but I do find there are many helpful and beneficial settings. So now, I'll move on to the custom settings and walk through the settings I personally use. I suggest only adding the ones that interest your own usage. Many of these settings can be used for experimenting or to help calibrate and get higher quality prints. Each setting has a technical description within Cura, but I hope this guide is clear and provides visual references for my settings. I will visually mark which settings can improve or affect quality or strength, are for experimenting or calibration, or are just for fun. First, to get to these settings, click Settings and configure Settings Visibility. I will jump right to the top with Quality Settings. Layer Height, for changing the height of each individual layer. You can see here the change from standard 0.2mm layer height with 100 layers to super quality of 0.12mm layer height with 167 layers. These thinner lines help hide the noticeable layer lines from 3D prints, but also requires more time. Initial layer height, for changing the height of the first layer, which I use for better bed adhesion. This just changes the first layer, so here the layer goes from 167 at 0.12mm to 166 at 0.24mm. Line width, for changing the width of a line corresponding to the nozzle size, which mine is 0.4mm. This can be adjusted for different nozzle sizes or attempting to print thicker and faster, like here from 0.4 to 0.6mm or to 1mm, although my 0.4mm nozzle can't handle this properly. This setting will also affect the walls. Infill line width, for changing the actual width of the infill lines. This one is for experimenting for faster or stronger printing with the infill. Initial layer line width, for changing the width of the first layer line, which can help with elephant's foot by shrinking slightly or other defects that can appear from the initial layer. There is also wall line width and more specific outer wall or inner wall width, top bottom width, skirt/brim width, and support widths, which can individually modify these respective widths. I found these settings extra for anything I have done, but maybe settings to look at for fixing or improving the corresponding setting. Moving on to the wall settings, wall thickness along with wall line count, for changing the wall width and or the number of wall lines multiplied by your actual line width. This changes the wall drastically from a single or double thin weak wall to a multi-thick strong wall. I believe this impacts part strength more than infill percentage. Z-seam alignment, Z-seam position, and seam corner preference, for changing the position of the seam or the starting point for each layer. There are a few options like user specified, shortest, random, or sharpest corner, and hiding or exposing the seam. I choose user specified and smart hiding to specify the position for each model. With the help of the access, here I show back right hides into the back right corner, or can do the front left corner, either hide the white dot into the shaping of the model. This can really help a print look clean. There are other wall options that I haven't found myself using yet, but we'll be looking into outer wall wipe distance and optimizing while printing in order to see what they affect if there is any significance. Moving on to the top/bottom settings, top surface skin layers, for calibrating the quality of the top skin on a print. Here I show the default of 0, the yellow lines for skin are smooth, or so a top surface face, and when changed to 5 affects the layers to top skin rather than the top surface quality. Top bottom thickness, top layers, for changing the thickness in height or layer count for the top face skin layers. Here the defaults are 4 top layers, which can be counted, and when changed to 12 accounts for that many top layers to fill, which can drastically affect printing time. And bottom thickness, bottom layers, and initial bottom layers for changing the thickness in height or layer count for the bottom face layers, similar to the top layers, just for the bottom or initial layers of the print. Top/bottom pattern, for choosing which pattern to use for printing the top and bottom layers. There are lines, concentric, and zigzag, which are all different and shown here, where the initial layer can be chosen separate to the other layers. I stick with zigzag, but feel free to try the others yourself. Bottom pattern initial layer, for changing the pattern for the initial layer if wanted, but I keep this as zigzag. Extra skin wall count, for changing the count of wall skin. This goes along with top surface skin layers. This cube here has the small skin layers here and can be adjusted to my liking. 2 or more walls make this skin just walls. At one wall there is some zigzag to fill this skin. Enable ironing, for choosing to finish the model with an iron or smoothing layer finish or not. This effect can look really nice or also not come out great at all, so try it out yourself and see. This will iron any or all top face layers, including this indented Z portion. Iron only highest layer, for choosing to iron only the last top layer of the model, opposed to any or all top face layers. This removes that Z portion. Skin overlap percentage, for adjusting the percentage of overlap between the top skin and the walls, which helps in connecting the walls to the skin. Looking at the walls or green here, at 10% overlap, there isn't much to see. Changing to something like 80% shows the skin here overlapping the infill and walls. This may help with any adhesion issues or filling some small gaps in the skin. There are other top and bottom options that I haven't found any significance of yet. Moving on to infill settings. Infill density, for changing the percentage amount of density of infill within the model. 20% is default, and something like 60% is crazy dense, and 2% is barely anything. I stick between 5 to 50% depending on wanted strength along with the wall width. Infill pattern, for changing the pattern type for the infill lines. There are so many here, so here's what they all look like. Grid, lines, triangles, trihexagon, cubic, cubic subdivision, octet, quarter cubic, concentric, zigzag, cross, cross 3D, gyroid, and lightning. I default to cubic subdivision or gyroid as these provide a good balance of strength and print time. Time-wise, cross seems the slowest for this cube, and cubic subdivision seems fastest, besides lightning, which seems to be very fast but weak infill. Connect infill lines for better adhesion between the infill and the walls. This option is default depending on the infill pattern. Turning this on adds a small line to connect the infill like this, opposed to no connections like this. This can slightly affect print time and strength, but I do leave this on. Infill overlap percentage, for adjusting the percentage of overlap between the infill and the walls. This can aid with adhesion, or it can be adjusted as needed. Along the walls, or green, you can see 5% overlap is not much, compared to like 60% where there is much overlap. Infill layer thickness, for changing the thickness or height of the infill lines, such as 1 layer thick or 2 layers thick. Can be something to mess with for saving some time on infill work depending on the infill pattern. You can see 0.2mm is the same as everything else, and 0.4mm will be thicker and be every other layer. 1mm is huge and probably will just fail. I just leave mine as the same as layer height. Gradual infill steps and gradual infill step height, for adjusting the infill to be more dense near the top skin layers, which can be given some certain height. Cubic subdivision, cross, and cross 3D hide this setting. For parts like this that don't need much infill, this can help save material and print time by being dense near the top. Here were a few different numbers and what they looked like. There are other info options that I haven't found any significance of yet. Moving on to material settings, printing temperature and printing temperature initial layer, for changing the nozzle temperatures or for just changing the initial layer. This temperature should be calibrated for each different kind of filament, brand, or even color or finish, such as PLA, ABS, silk PLA, marble PLA, or other crazy filaments. I have found for my basic PLA filament, 200 to 210 degrees Celsius works out great. Also keep in mind for all temperatures, it requires heat and energy, which costs more money. Initial printing temperature and final printing temperature for adjusting the minimum temperatures to start printing, or for when the print stops printing and starts to cool off. This can help a print start slightly faster than waiting for the max temp, so I think I will make the initial temperature a few degrees cooler, like 200 degrees C. Build plate temperature and build plate temperature initial layer, for changing the bed temperature or just the initial layer. Calibrating a nice and cool temp that works with your bed type can help use less energy and save some money. I put my initial temp higher at 60°C for first layer adhesion, and then slightly cooler at 55°C for the rest of the print, which works great for my glass bed. Flow, for calibrating the correct flow percentage for accurate part dimensions. This can make the lines printed more thick or thin, and should be the same thickness as the line width for accurate measurements. In a future calibration guide video, this will include calibrating this flow setting for your printer. The other flow options of wall flow, top and bottom flow, infill flow, skirt/brim flow, support flow, and initial layer flow can all be used to dial in specific flow rates for accuracy across all printing line types. Most of these other material options seem to be hitting, so I ignore them. Moving on to the speed settings. Print speed, for changing the overall max print speed. This can affect the print time, but it is not a linear relation and can affect print quality big time if too fast. 20mm per second will print slow, 50mm per second is default, and 100mm per second will only print slightly faster than the default of 50. This should be tuned for a balance between speed and highest quality. Infill speed, for changing the max infill speed. Infill is the inside of the part, so can possibly be bumped up for faster print time without much outside quality reduction. Wall speed of inner and outer walls, for changing the max speed for both inner and outer walls. Again, the inner walls are on the inside and can be bumped up without affecting too much quality. This is one of my favorite time-saving hacks, as you can see here where I save over 2 minutes for inner wall lines with this already short print. Top surface skin speed, for changing the top skin speed to hopefully increase quality if needed. Top and bottom speed, for changing the speed for the top and bottom layers to hopefully improve bed adhesion and or overall top and bottom quality if needed. I leave mine as is. Support speed, for changing the speed of the support structures if needed to speed up or slow down support lines. I leave as is. Travel speed, for changing the speed when traveling across the bed if needed. I have not experimented too much, but try it out yourself to see what time you can save for travel movements, without sacrificing print quality. Initial layer speed, for changing the initial speed to help with putting down a nice adhesive first layer. Don't print the first layer too fast. I leave mine at a slow 20 mm per second. Skirt/brim speed, for changing the speed of the skirt or brim, which can slightly improve the start time for a print for only these preparation lines. Z-hop speed, for adjusting the speed of the Z-hop motion, which Z-hop is under the travel settings. Number of slower layers, for adjusting the number of slower layers to aid with putting down adhesive starting layers. This can really help with more wide and flat parts to stick fully to the bed. I may adjust this if the part is taller than it is wide. Most of these other speed options seem to be hidden, so I also ignore them. Moving on to travel settings. Enable retraction, for choosing if retraction is enabled or not. Retraction is when the filament goes backwards and needs fine-tuning to really improve quality and lessen or remove stringing defects. This is another setting that will be featured in a calibration video. Retract at layer change, for choosing if retraction happens at a layer change or not. I use this feature to hopefully avoid any blobs that may get stuck anywhere on the print. Retraction distance and retraction speed, for adjusting and aiding in calibration for improved string quality of hopefully no strings or wisps. These will be the two settings to dial in for perfect retraction. Retraction minimal travel, for changing the minimum travel amount before triggering a retraction. In other words, this amount must travel for a retraction to occur. Maximum retraction count and minimum extrusion distance window, for setting up a limit of how many retractions can occur in a printing area, which you can see here reduces retraction by a small amount. This will really help avoid too much retraction and potential grinding or flattening of the filament at the extruder gear. These settings may be needed with more complex prints that extrude in small amounts, a setting to keep in mind. Limit support retractions, for changing the limit for support line retractions. Since support don't need to look pretty, this can save some time. Combing mode, for selecting if combing mode is enabled or not. Combing mode makes travel movements only within the printed part area, keeping any extra ooze inside the printed part. As you can see with combing off, there are a ton of direct travel movements, making a fast print. But with combing on, there are more combing travels, reducing any oozing or blobs, so adding travel time, but reducing retraction, so saving overall time and also improving the quality. One of my favorite settings to experiment with and use for a high quality looking print. Max comb distance with no retraction, for changing the max amount of travel distance before retractions get triggered. This allows for less to no retractions, saving retraction time, and any oozing will only get trapped inside the part instead of potentially affecting the outside quality. Retract before outer wall, for selecting if a retraction is triggered before moving to print the outer wall line or not. I use this hoping to help with the outside wall quality. Z-hop when retracting, for selecting if a Z-hop will trigger or move slightly up out of the way during a retraction, hoping to avoid the print while traveling around or not. Z-hop height, for changing the height of the Z-hop motion or how high the machine moves during a retraction. I make this height the same as the layer height for a nice safe distance. There are other travel options that I haven't found any significance of yet. Moving on to cooling settings. Enable print cooling, for selecting if the print cooling fan is enabled or not. Print cooling is definitely important for many materials, so this needs adjusting per filament material. Poor cooling can cause printing defects or even failures. Fan speed, for changing the speed at which the cooling fan is spinning at. With PLA, I keep this at max 100%. Initial fan speed, regular fan speed at height, and regular fan speed at layer, for setting the initial fan speed curve. The cooling may affect first layer adhesion, so starting with no cooling helps the first layer adhere properly, then can ramp up to max cooling at some height or layer for the rest of the model structure. Messing with the minimum layer time, speed, or lift head setting may be needed if cooling is not enough at the print speed, so more cooling time is needed. I have seen many cases where these settings affect a print poorly because the nozzle oozes and causes defects or a print failure, so be cautious with this setting. Moving on to the support settings. Generate support, to select if supports can be enabled or not. Supports can be very important or a must-have for some complex models and overhangs. The support is the cyan colored lines. Some fine-tuning can be made with more settings to improve the model and ease the support removal process. Support structure, For selecting between normal, multi-support, or tree supports, which are more angular and selected supports and can usually break off easier than normal. Supports may differ depending on the model structure, so this setting I adjust a lot for every model sliced. There are 2 settings specific for trees, and the rest affect both support structure types. Tree support branch angle. For changing the angle of how the tree support is generated, adding steeper angles for hard to reach places, or less steep for other structure. Here at 80 degrees, it generates a very slow ramp up compared to like 10 degrees, which has a very steep ramp up. Tree support branch distance. For changing the distance between the branches of the tree support structure, so the gap between one support point and another support point. The closer the gap, like at 1mm, the more support points to remove, and the wider gap at like 10mm, the less supporting points to remove. This was hard to see with the Charizard model, so just look close and aim for a nice balance, which the default of 1mm seems to work out most of the time. Support placement. For choosing the type of placement, being everywhere, even potentially in or on the model, or only touching the build plate. When using everywhere, there is some support generated over the top of this model, which can either fail or reduce quality in that area. When using touching build plate, it removes any support over the model, keeping a real nice and clean surface, yet still supports. I mostly use touching the build plate, but do adjust for each model sliced. Support overhang angle. For changing the overhang angle, from 0 degrees for supporting all overhangs to 90 degrees for supporting no overhangs. Here with 70 degrees, it only generates this much support compared to here with like 20 degrees, generating much more support, maybe excessive. Another setting I change for each model. Support pattern. For selecting the pattern of lines for the support structure, similar to infill patterns, which can affect the area that the model needs supporting. Here's what they all look like for lines, grid, triangle, concentric, zigzag, cross, and gyroid. I leave it on zigzag, but might experiment more with concentric or gyroid. Connect support zigzags. For selecting if connect support zigzags are enabled or not. This can slightly increase strength, but I find it unnecessary, and leaving this off might ease with removal, unless I spot an issue that might occur. Support density. For changing the percentage amount of density for the support structure. The lower the density, the harder to support the model, and vice versa. 20% is default, and 60% is really chunky supports. I keep this percentage lower from like 5 to 20% to have thinner and easier to remove supports. Enable support brim. For selecting if the support will have an attached brim or not. This can really help for when a support is really thin and needs better adhesion to not fail. I usually leave this on. Support Z distance and support top distance. For changing the distance between the top of a support structure and bottom of the model. This is the general distance for the Z gap between support and model. This distance is rounded to match the layer height. The default is the layer height, so anything smaller won't apply besides 0 distance, which would stick to the model, and something larger like 2mm leaves a huge gap that won't support the model at all. I recommend only 1 to 2 layers of gap. Enable support interface and enable support roof and floor for allowing these next settings to be active. The interface is really helpful and can be seen by the darker blue lines. I find this to be the most important part that supports the model, so definitely leave it on. Support interface thickness and support roof and floor thickness. For changing the thickness of the support at the floor with placement everywhere, or adhesion to the top parts of the model for the support base, or for the support at the roof for leaving enough area to support the bottom part of the model, where 0 has no thickness or blue lines. Support interface density and support roof and floor density. For changing the density of the support at the floor and roofs, which affect the support removal process. I like to have a low floor of like 10 to 20% density for removal and a high roof density of like 50 to 60% to have a nice dense area where the model can print on as seen here. With only touching the build plate placement, the support floor is removed. There are many other support options that I haven't found any significance of yet. Here is an example to show how I look at and interpret supports. For this Omni wrench I made for a friend, I need sturdy supports to support the long and thin floating handle in this orientation. I'll use normal supports, only touching the build plate, since that's all I need to support. I give an angle like 40 degrees that ensures the support will generate. I up the density to about 15% and then leave support brim on because it is a very thin structure, and sadly did in fact fail on me. So I'll continue to mess with the angles, densities, distances, and sometimes more to make sure it's good enough for my liking, and here the supports seem to do the job, covering enough area to print. My roof density works well to support all these different areas, so with all of that, this slice model looks great to me and should print well. Moving on to build plate adhesion. Build plate adhesion type. For selecting the type of adhesion of skirt or brim or raft. A skirt is just a small amount of prime surrounding the model. A brim will surround the model too, but then close and connect with the first layer of the model to enhance bed adhesion, especially important for thin or small contact points. A raft is a thick bed that is printed underneath the part, where rafts can help if you have bed adhesion problems, but I have not used rafts since I mastered bed leveling. Skirt line count and skirt distance, for changing how long or how many circular lines the skirt is around the model. Brim width and brim line count, for changing how long or how many circular lines the attached brim is. Adjust these values to enhance bed adhesion or to waste less priming material. There are other raft settings for a similar thing of raft layers, layer thickness, line width, speed, and more, which are all fairly simple to mess with. The default rafts have always worked when I did use them. I don't have dual extruders, so I have no input on any of these settings. So moving on to mesh fix settings. Maximum resolution, for adjusting the resolution of the sliced model. Increasing the amount lowers the resolution and thus renders less G-code for the machine to try and run. Decreasing increases the resolution and might overwork your printer with too many G-code commands. There are other mesh options that I haven't found any significance of yet. Moving on to the special mode settings. Print sequence, for changing the sequence of printing with multiple models. This can print one model at a time and reduce stringing and travel. I personally have tried printing one at a time and had my biggest failure. This setting might require a really sturdy and level bed to allow for a constant bed adhesion for each individual print, so be cautious, but is a cool setting nonetheless. Otherwise, it defaults to all at once where there are travel movements between parts. Spiralize outer contour, for selecting if the model should be sliced with only the one thick outer wall, which gets spiralized and has no Z-seam or layer changes. This is great for vase or holotype models. This can drastically improve outside print quality as it removes the seam or any retractions and movements, so try it out with some cool models. Moving on to the last one of experimental settings. Fuzzy skin is a fun setting that can give the model some texture, but greatly affects smooth quality. This is definitely for fun or for effects. There are so many settings to look through, but I hope this narrowed down some important settings, which some I really do change between almost every print. Make sure to check out some more of the special ones below to find something that may interest you. Thank you so much for watching. These have been over 100 different slicing settings, so let me know what your favorite setting is in the comments below, and I'll see you in the next video.